Hey everyone, so in this video we're going to be talking about dot product of two vectors. Okay, the dot product of two vectors. Now let's dive into it. So what is the dot product? All right, so imagine if we have two vectors A and then B. So the dot product is written as A dot B. Okay, A dot B, and it is also known as the scalar product of two vectors. So we can call it the dot product, or we can call it a scalar product. And this is because the result is a scalar product. Okay, it just gives us a single number. It can be negative, positive, or maybe sometimes zero. But the idea is that it gives us a scalar product. So how do we go about this? How do we calculate the dot product of two vectors? So just clear this. Now, we're given a question. Find the dot product of the two vectors. So we have A is 2i minus j plus 5k. Okay, and B is 4i plus 2j plus 3k. So the I, j, and the k just represent the x-axis, the y-axis, and then the z-axis. Okay, so that's just what it just shows you a direction. All right, so we have the I represent the x-axis, j represents the y-axis, and then k represents the z-axis. So let's try to do this. Okay, so we have A is 2i minus j plus 5k. So we want to find A dot B. Okay, and then B is 4i plus 2j plus 3k. So what we do, we group the i's and the j's and the k's together. Okay, so we just multiply. So we have this one and this one. Okay, this one, this one, this one, and this one. So what we have is something like this. So we have 2 times 4, because those are the ones that are bearing the I. 2 times 4, there it is. Okay, plus another bracket. This is j. So what was the coefficient of j here? You can see there's a minus here, so it's minus 1, because minus 1 times j is the same thing as minus j. So the coefficient of j here is minus 1. Okay, so I have minus 1 times 2 plus, okay, for the case, 5 times 3. Okay, so we multiply the coefficients of each, all right, and then add them together. So 2 times 4 will give me 8. Minus 1 times 2 will give me minus 2. Okay, and then 5 times 3 will give me 15. So remember, since we're opening this bracket, plus times minus will to give us minus. So we have 8 minus 2 plus 15. So 8 minus 2 will be 6 plus 15. So our answer will be 21. So hence, the dot product of, so we can write A dot B is equal to 21. So it means the dot product of these two vectors is 21. Okay, so let me clear my drawings. Okay, and I can write here. So you can see, just use this. So A dot B is equal to 21 as my final answer. Okay, if you have any questions or disagreements, you can also let me know. So let's move to the next question. So before we move to the next question, let's try to get the general formula for finding a dot product. So supposing we have, let's say, you can remember, write the vectors in I, j, and k, right? Supposing we have, let's say, a1i plus b1j plus c1k. Suppose, let's say vector A is this, And then vector B is A2I plus B2J plus C2K. Now, normally we actually put something like an arrow here, but I'm unable to do that because of the font. So normally we put arrows to show that these are vectors. Okay, normally when you're writing it, it's always good to put the arrows. So the formula will be, so generally A dot B will be, so like I said, we take the coefficients, so it will be A1 times A2 plus B1 times B2 plus C1 times C2. Okay, so if I put A dot B, so this is the general formula, this is the general idea. Okay, we put the, those bearing I's together, those bearing J's together, and those bearing K's together. So if peradventure, let's say, if this was minus, okay, if B was A2I minus B2J plus C2K, then here, we don't have to change this, we just go ahead and change this. So our answer here will be minus, and then if you open the bracket, it can still give you minus. So we focus on what's inside the bracket first, okay, and then we can open the bracket. That's just the general idea. Now let's move to the next question. All right, so let's find the dot product of these two vectors. So we have 3i minus 7j plus k, and then we have 2i plus 2j minus 5k. So let's put all the i's and the j's together, multiply them together. So let's do this together. So we have 3 times 2, right, plus minus 7 times 2 plus, so what's the coefficient of k here? That's 1, because 1 times k will be equal to k. So we have 1 times minus 5. So 3 times 2 will give us 6 plus minus 7 times 2 will give us minus 14. And then 1 times minus 5 will give us minus 5. Well, let me just put it in bracket first, sorry. Wait, let me write it well, sorry. So again, 3 times 2 will give us 6 plus minus 7 times 2 will give us minus 14. Let me just put it in bracket plus 1 times minus 5 will give us minus 5. And then we open the bracket, so we have 6 minus 14 minus 5. So minus 14 minus 5, that's minus 19. So we can say 6 minus 19, which will give us minus 13. Or we can write it like this. So let's say 6 minus 19. The same thing as minus 19 minus 6. Our answer will be 19 minus 6 is 13. And then our answer is still minus 13. So meaning A dot B is equal to minus 13. Okay, so I'll use a red pen to mark it there. Let me clear out the drawings. So it means that A dot B equal to minus 13. Okay, now sometimes we're now asked to find the angle between the two vectors. Okay, so sometimes we're given the vectors A and B, find the dot product, and then we're asked to find the angle between the two vectors. So there's also a formula we can use and say A dot B will be equal to the magnitude of A, which is like this, times the magnitude of B cos theta, where theta is the angle between A, vector A, and B. So write it like this. So A dot B equals magnitude of A times magnitude of b cos theta. Okay, so let's see if we can try and find the angle between these two vectors. So first of all, okay, so if we make cos theta the subject of the formula, so we can have that. So let me erase this quickly. If we make cos theta the subject of the formula, we have that cos theta will be equal to a dot b over the magnitude of a times the magnitude of b, and then we can find our theta. Okay, so let's see if we can find the angle between these two vectors, a vector b. Now we know that a dot b is equal to minus 13. So we need to find the magnitude of a and the magnitude of b. So clear. So let's start with a. Okay, so just definitions. So suppose we have a vector. Let's just say vector a, where we have let's say a1i plus b1i, b2j, sorry, plus c1k, where a1, b1, and c1 are actually values. Then the magnitude of a equal to, then we have the square root of a1 square plus b1 square plus c1 square. Okay, that's just how it is. We just find the sum of the three squares, and then we find the square root. So for this one, we have this vector. The value of the magnitude of a will be, okay, the square root. That will be 3 square plus minus 7 square plus 1 square. So we have 3 square will be 9. Okay. Minus 7 square, that's 49. So when you square a negative value, it gives you a positive answer. Okay, that will be 9 plus 49 plus the square of 1 is also 1. Okay, so 9 plus 49 plus 1. So we have 50 plus 9, which is 59. So we have the magnitude of a here as root 59. Okay, sorry about my 9, looks like Q. Sorry. Okay, so I'll just use the red pen here so that it's permanent. So we know that the magnitude of a here is root 59. So let's try and get the magnitude of b. Okay, I'm just gonna erase this part. Oh, sorry. I'm just gonna put this back, so it should be have a1 square plus b1 square plus c1 square. So now for the magnitude of b, okay, let's put b here. So we have, let's put the square roots. So if we start with number 2, so we have 2 square plus another 2 square plus minus 5 square. So it's always good to put the minus in brackets so that you can avoid confusion. And then you open the bracket later. All right, so if we expand this, we'll have 4. So let me put the square roots. Let's not forget our square roots. So we have 4 plus 4 plus minus 5 square, that's 25, plus 25. Okay, so we have 8 plus 25, which will give us 33. So it means The magnitude of b is root 33. And now put that in red again. The magnitude of b here is root 33. Okay, so we have a dot b as minus 13. We know that the magnitude of a is root 59. The magnitude of b is root 33. So from there we can find our theta. Let me clear the drawings again. Okay, so we know that a dot b equal to the magnitude of a times the magnitude of b cos theta. And if we make cos theta the separate the formula, we have cos theta equal to a dot b over the magnitude of a times the magnitude of b. So we already have our value, so we have minus 13 over root 59 times root 33. Okay, so if I use my calculator, so I'm just going to use my calculator. This will give me 59 times 33. Will give me somewhere around minus 0. I'm just going to put in decimals first. Minus 0 .2946. I'm just use 4 decimal places 46. So we want to find theta. We have to find the inverse cosine of. So you can do this directly. You can find the what do you call this? The inverse cosine directly. Okay, or you can just find the inverse cosine of minus 0.2946. So it becomes minus 0.2946. Okay. The inverse cosine of minus 0.2946. Okay, that will give me 107.13. Okay, because the next on the calculator, the next value is still a 3, so we can leave it like this. So 107.13 degrees. So the angle between these two vectors is actually 107.13. If you want to make it like whole number, you can just leave it as 107. So it's up to you how you want your decimal places to be, depending on the question. Okay, so I usually like to leave it as 2 decimal places. So a dot b is minus 13. The magnitude of a is root 59. The magnitude of b is root 33. And the angle between a and b is 107.13 or 107.13 degrees. All right. So now find the dot product and then find the angle between the two vectors. So we have vectors a and b. So again, now you can see I've written it in bracket form. So it's still the same. Okay, so the first number represents the x-axis, the second number represents the y-axis, and then the third number represents the z-axis. And we can still write it as 2i minus 3j plus 6k. And here we have minus 8i minus j, because the coefficient of j here is minus 1, and then plus 4k. So you can write it in either way. It depends on how you want to write it. So as long as you know that they're both the same and you don't confuse yourself. So again, let's find the dot product. So we take the x's or the i's together, the j's together, and the k's together. So 2 times minus 8. So I have 2 times minus 8 plus these two. minus 3 times minus 1 plus 6 times 4. So 2 times minus 8, that's minus 16. Okay, I'm just putting brackets, plus 3 minus 3 times minus 1. So minus times minus will give us plus. That will be 3. Plus 6 times 4 will give us 24. So we have minus 16 plus 3 plus 24. And 24 plus 3, that's 27. So we have minus 16 plus 27, which is the same thing as 27 minus 16. And our answer will be 11. So it means that the dot product of these two vectors, A and B, A dot B, will give us 11. All right. So now find the angle between the two vectors. So let me just make the 11 permanent with a red pen. So let me clear all this. So we know that let's go. A dot B is equal to 11. Okay. So let's find the angle between the two vectors. So remember the formula that A dot B is also equal to the magnitude of A, sorry about my magnitude, times the magnitude of B cos theta. And if we make cos theta the subject to the formula, we have cos theta equals A dot B over the magnitude of A times the magnitude of B. Okay, since we already know our A dot B, let's find our magnitudes. So again, using the formula, so we have a vector A, let me just put it here. For reference, if we have let's say we have a vector, let me just use another vector X, okay, which is equal to, let's say, A1I plus B1J plus C1K, then the magnitude of X will be equal to square root A1 square plus B1 square plus C1 square. All right. So for our vector A now, so here we have, so square root 2 square plus minus 3 square plus 6 square. Now 2 square is 4, forget our square root. Plus minus 3 square is 9, and 6 square is 36. Okay, so 4 plus 9 give us 25, and plus 36. 25 plus 26 will give us 161. So we have root 61. So the value of the magnitude of A is root 61. So I'm just going to put it here again. So we have magnitude of A equals 61. Okay, now let's go for B. Magnitude of B equal to square root minus 8 square plus minus 1 square plus 4 square. So minus 8 square will give us 64. Okay, plus 1 plus 4 square, which is 16. Okay, this is 65 plus 16, which is root 81. And square root of 81 is actually 9. So here we actually have a whole number, okay, which is 9. So the magnitude of B here is just 9. So I'm just going to put that down again. So we'll have that equals 9. So we have all our values. So let's try and find theta. So remember that I'll just go directly. So we have cos theta is equal to a dot b over the magnitude of a times the magnitude of b. So we have 11 over root 61 times 9. Okay, so we can say that theta equals to the inverse cosine of 11 over root 61 times 9. Okay, you can do this directly on a calculator, or you can decide to find this first and then find the inverse cosine. So let's try both ways. So first of all, I'll do it directly on my calculator. So we have the inverse cosine function of 11. Sorry. Okay. So we have the inverse cosine function of 11 over root 61 times 9. So directly it gave me 80.9968. Okay, we have 80.9968, but because we have 9 now, we can just simply approximate to 81. Okay, so we have 81 degrees. Okay, but if I don't do it directly, so let's say I find 11 divided by root 61 times 9 first, and then find the inverse cosine. So let me do that here. So if we say 11 over root 61 times 9, we get 0. I'll put it in 4 decimal places just to increase the accuracy. 1565, because it's actually 1.648, but the number before, the number after the 4 is 8, so we can run it up to 5. So we have the inverse cosine of this value, and if we find the inverse cosine of 0.1565, we have 80.9961. I'm just showing you the difference. So the difference isn't much, so it's still 81 degrees. So in both cases, we have very similar answers. Okay, so it means the angle between these two vectors, A and B, is 81 degrees. So again, I'm going to put this in red for our final answer. So I have theta is equal to 81 degrees, where theta is the angle between A and B. Okay, so we have our answers. The dot product is 11. The magnitude of A is root 61. The magnitude of B is 9. Okay, and the angle between the two vectors is 81. Now, I'm still going to do some more videos about, let's say, let me just clear this. Let's say the angle between a vector and, let's say, the x-axis, the y-axis, and the z-axis. Okay, so we are trying to find the angles B to add. Let's say we have a vector, let's say A, and then you are asked to find the angle between this vector and then the x-axis or the y-axis or the z-axis. Okay, and then I'm also going to make some more videos about we have the cross products. Okay, also finding the angles between the two vectors. So just giving more options and more things to, more problems to solve and all that. And I hope you guys stick around and, you have any questions, you can always let me know. And then I think that's it for this one. Now let's go to the last one. I think I put one more. Okay, thank you very much for sticking around. Clear this. Okay, let's now try these ones. Okay, find dot product and find the angle between the two vectors. So we have again A and B. So it's up to you if you want to now write it in IJK form, but you can just do it directly. So let's try and be much faster now and try to do it directly. So we have A and B. So A dot B. So let's take this together, these together, and then these together. So we'll have 2 times minus 5 plus minus 1 times 7 plus 2 times minus 4. Okay, so we have minus 10. Let's put everything in bracket. Plus minus 7 plus minus 8. So we open the bracket, we have minus 10, minus 7, minus 8, which will give us minus 25. Or we can say this the same thing as minus 10 plus 7 plus 8, which is minus 25. Open the bracket is still minus 25. So we've established the fact that A dot B here is minus 25. So let's put that in red. So that A dot B is minus 25. All right. Now to find the angle, we remember the formula that A dot B is equal to the magnitude of A times the magnitude of B cos theta. Okay, so let's find our magnitude of A and magnitude of B. So again, we're trying to be a bit faster now. So from what we know that we want to find the magnitude of A, that will be equal to square root 2 square plus minus 1 square plus 2 square. Equal. So that 2 square is also have 4 plus minus 1 square is still 1 plus 4. So 4 plus 1 plus 4 will give us 9. Okay, we know that the square root of 9 is equal to 3. So it means that the magnitude of A here is equal to 3. So we write that down. So magnitude of A is equal to 3. Okay. Let's try B. So that for B, the magnitude of B will be equal to the square root of the sum of the squares, minus 5 squares plus 7 squared plus minus 4 squared, which is equal to 25 plus 49. Okay, the square of minus 4 is to 16, so plus 16. So 25 plus 49 plus 16, that should give me somewhere around 90. Yes, 90. Okay, so we can leave it like this. Okay, I'll put it in a sort form. Okay, so this root 90 is okay, and then we can decide to go further and say, oh, 90 is the same thing as 9 times 10, right? So we have 9 times 10, which is the same as root 9 times root 10. So root 9 here is already 3, and then root 10 stays the way it is. So it means that the magnitude of b can either be, you can say, root 90 or 3 root 10. Okay, some questions might put root 90, some questions might put 3 root 10, or some question might ask you to put it in short form. It depends on how you want to do it or how the question asks you to do it. So we have the magnitude of b here will be 3 root 10. Okay, now we'll have all these values. So again, so cos theta will be equal to a dot b over magnitude of a times magnitude of b. Okay, so it means we have minus 25 over 3 times 3 root 10. So 3 times 3 root 10 will actually be 9 root 10. Okay, so just talking about, so if you have something like this, you have a times b root c. Okay, it will give us kind of like a times b root c. So 3 times 3 root 10 will give us, 3 times 3 is 9, and then root 10. So we have minus 25 over 9 to 10. So let's do it. Let's do it step by step. So what is minus 25 divided by 9 root 10? So in the calculator, give me minus 0.8784. I like to go for 4 decimal places. Okay. And then the cosine, so we want to find theta, so it will not be the cosine inverse, sorry, the inverse cosine. So cos minus 1 of this. So if we do that, we have 1 of minus 0.8784. Get our angle as 151.45 degrees. Okay, because actually we have 151.4599, so we can approximate it as 151.45 degrees. So our angle here is 151.45. Okay, and if we decided to do it directly, so if instead of doing it step by step, we just say just find the inverse cosine of this. Okay, we should get, let me try that. We should get so here I'm getting, so then I'm getting 151.45. Yeah, same thing. So after that is 451. So the answers are more or less the same, just like 0.00 differences, 0.001 to like that. All right, so we established our answers. So A dot B is minus 25. The magnitude of A is 3. The magnitude of B is 3 root 10, and then the angle between, so theta, sorry about my theta, is equal to 151.45, 151.45 degrees. Okay. All right, so I think that's just it for now. And then we can also try these. I think I put some here. You can try these out and see if you actually get it. And if you have any questions, leave them in the comments. So leave your answers in the comments, and I'll also I'm going to put a link to a PDF where I also explain some of the answers and other things regarding dot products and angle between the vectors. So this is where I'll stop, and I just want to say thank you If you made it this far, I really appreciate. And then again, if you have any questions or reactions, let me know in the comments and I'll make sure to attend to everything. So have a nice day, and you